Hi, today we're going to be talking about causation. So from the previous mini lectures on correlation, you've learned that to demonstrate a relationship exists between two variables numerically, we establish what's called a correlation. But how does correlation figure into causation? And what elements do we need present to really say that we are sure that one variable is causing a change in another variable? Now, we've got 4 requirements for us to infer causation. Most social scientists believe these things need to be met in order to say with good faith that A causes a change in B. 1, we need to establish a correlation. Now, like I said in the previous videos, correlation does not always mean A causes a change in B. All it simply means is we've demonstrated a relationship exists between two variables. They could both increase at the same time, or as one increases, another could decrease. So if we're saying that one causes the other, there definitely has to be a correlation between the two. 2, we need to establish what we call temporal order. Now, temporal is just a fancy word for saying time. So we have to establish that the cause comes before the effect. Now, this is a great chance for us to examine before and after methodology, and also using control group methodology, where we as researchers are really sure that the independent variable, or the cause, comes before the effect because we have control over it. The third variable, or the third element we need to ensure for causation, is that we need to eliminate other plausible alternative causes. This means we need to control for other variables that could result in our change in our dependent variable. Recall the Harvard study on drinking soda and teenage violence and carrying handguns. They did not control for a very important spurious cause, which was poverty level or SES, and therefore their insistence that those two variables were related was not true. And finally, the fourth element we need to ensure that one variable causes a change in the other is that there has to be a rational or logical explanation. Now, this might not always be mentioned in the literature that you read, but we have to assume this is pretty basic stuff. This is not rocket science. This just means we want to make sure that there is a reason that we're saying these two variables have a relationship. It could be based in existing knowledge. It could be based in existing theory, but we need to say, yeah, we think these things are related for a reason. Take, for instance, the study I showed you in the last video on sour cream consumption and motorcycle accident. Is there any theories that could possibly cover why sour cream would cause motorcycle accidents? No. There is no rational or logical explanation of why those two variables should be related. So therefore, we cannot say in good faith that sour cream causes motorcycle accidents. Now, we might have survey data from running a survey, or we could have existing administrative data like from the QPS or from the Australian Bureau of Statistics. And it's easy using that data to prove that a correlation exists. We can pop it into a spreadsheet, put some statistical software, run some functions on there, and it's not hard to determine that a relationship exists. Now, these days we always run our data in a computer program, or we analyze it using statistical software. The most basic would be using Excel. The most complex, we'd be looking at things like Stata, or a program called R, but you might hear other terms like SPSS, SAS, other sorts of statistical software packages that can run very simple equations like correlations. You'll learn about these in your statistics class. By using software, we can very quickly tell if a correlation coefficient is positive or negative, and if it's close to 1 or close to -1, then we know we've got a good correlation. However, if it's really close to 0, we can rule out right from the beginning that our suspected variable isn't a causal variable for our dependent variable. Now, what if we have to run a quasi-experiment, or what if we're relying on retrospective data? As we know in social science research, we as researchers don't always have control over our variables. Sometimes retrospective research, we can't 100% establish one thing came before another. However, if we take things like childhood experiences and their effects on adult elements in your life, like getting involved in the justice system, then we can infer temporal order. That means that we can estimate it. So we know if you were in the foster system as a child and now you're involved in the criminal justice system, we know that being in the foster system came first. That's pretty logical. If we're interested in people who are strongly attached to their parents during childhood, and if those people commit less crime as adults, we clearly can see that attachment to your parents comes before anything happens when you're an adult. Now this gets tricky when we're thinking about things that might come along the same times. So maybe the advent of high school, and is that related to an increase in violence? Or when you're starting university, and do you experience more depression symptoms? So we have to really be careful and say with really good faith that we can establish temporal order. For retrospective studies, we kind of use logic, but it's not possible in all cases. Now, if we have information about both those elements, temporal order and correlation, and we go, boom, yes, I've got a correlation, pretty strong correlation, and I can estimate or I can guarantee temporal order. In a case, if I was using logic to infer that it came before the outcome, then it would kind of like be using an after the fact method. So I've got data, yep, it's got a correlation. I'm looking into the past, so ex post facto research, kind of like using after the data or after the fact method. So we think about a cause for having food poisoning. You might wake up in the morning with a horrible case of food poisoning, and you want to start eliminating suspects. You say, well, I didn't eat anything after I went to that restaurant and had that raw chicken, so I'm pretty sure it was the food that I ate, and then my stomach pain started. However, if you didn't have stomach pain until you had stomach pain before you ate, you can't be sure it was the chicken. Now, think about the types of methodologies we've discussed so far. If we think longitudinal data, so looking over time at particular variables for a similar group or a panel, it can provide us really good evidence of temporal order if I can't determine whether a cause came before or after a change in the outcome through logic alone. So following somebody throughout their teenage years, then I can definitely be sure, or I can be more sure about temporal order than if I was to just do a retrospective study. Here's an example. In a longitudinal study at time 1, I might measure how many delinquent acts occur each week in a primary school. Then I might have a new program started in the school where kids are focusing on the high five, okay? And this is conflict resolution, mediation type stuff. And then at time 3, I can remeasure how many delinquent acts occur in each week in the same school. So I can be really sure from time 1 to time 2 that a difference did occur and it was attributable to my independent variable. So if I had information about a correlation and temporal order with longitudinal data, it would be like what we have with the before and after method. So comparing time 1 to time 2, and I can really be a lot more sure about temporal order than just using the ex post facto method. Now, what about this third element of eliminating plausible alternative causes? So this is where we as researchers need to be sure we're on top of the literature, if other people have explored this before, or if other people have thought of things that could account for variations in our data. That's really tough to do with survey or existing data. If I just see numbers on a screen, it's kind of hard for me to take into account everything I'm supposed to. But this is what control group methodology does best. Like we say, it controls for other elements. And we'll talk about what that historical rogue and what this term, a threat, would be next week when we discuss validity. So if I'm using experimental or quasi-experimental methods, remember the difference between the two, the control group method can easily establish for me all three major elements necessary to infer causation. A correlation, looking at the differences between group 1 and group 2. It can establish temporal order because I can be really sure about when the independent variable was exposed or when the participants were exposed. And because I'm using two different groups, boom, I can really eliminate other plausible alternative sources. If I'm using survey or existing data, I can easily establish a correlation with a computer program. I can pretty easily establish temporal order if I'm using logic, okay? Or if I'm using a longitudinal format and comparing time 1 to time 2. But it's a bit more difficult to establish no spurious causation or no spurious causal relationships because, like the researchers in the Harvard study used, they had really good data, but they failed to account for a confounding variable or one that was responsible for both drinking soda and for teenage violence. So I can only totally eliminate plausible alternative causes if I have measures of all possible alternative causes in our data. Well, that's very difficult to do. But this is why we use control variables, because if I have measures of the most likely possible alternative causes, then by using statistical software, I can ensure I'm not misled, okay? Age, race, gender, SES, level of education, all of these things that commonly might affect my dependent variable, if I can get measures on those things, then I can control for them statistically. Okay, so they're more important than you might have initially thought. So in summary, the main requirements to establish causation are 4: correlation, establishing temporal order, eliminating possible alternative causes, or we call this spuriousness, and then finally, having a rational or logical explanation. Again, that's pretty common sense. You might not always see that mentioned in the literature, but the top 3 for sure. It's not terribly difficult to show that a relationship exists between two variables. Looking at motorcycles and sour cream. It's not that difficult. We just have to put data points into a program. Longitudinal data and sometimes logic can help establish temporal order for sure. So again, a little more difficult to establish that, but if we really use logic and common sense, we can probably get there. Now, the most challenging part about saying one variable causes a change in the other and being really, really sure about it is to establish whether we have eliminated all the plausible alternative causes. The control group method does this best in a rigid experimental situation where the researcher has control over everything. Now, I might be able to approximate this sometimes if I'm using existing data, but I can't do it with 100% certainty as if I could using the control group method. Thank you for joining me.